Hello everybody, welcome to UGC EPG Pathshala. I am Dr. Seema Mehra Parihar, who has been teaching remote sensing and GIS now for the last 30 years. I have had my share of learning from Indian Institute of Remote Sensing, Dehradun, and had my postdoc fellowship at ITC Netherlands. My PhD is on Natural Resource Management from Department of Geography, Delhi School of Economics. Let's move ahead and talk about network analysis in GIS. The learning objectives of this lecture are: 1. Concept of network analysis and understanding of the networks. We'll also talk about the type of models in network analysis. We'll talk about different operations for network analysis, and also at the end we'll be talking about the application of network analysis. To begin with, let's talk about the concept. Network analysis is an operation in GIS which analyzes the data set of geographic network or real world network. Network analysis examines the properties of natural and man-made network in order to understand the behavior of flows within and around such a networks and locational analysis. It focuses on edge node topology to represent real life networks of information. It's function based on the mathematical subdiscipline of graph theory and topology. And plus you also all have to remember all those lessons which you have learned till now. You remember your raster and vector data knowledge. You also remember your raster and data models knowledge. You pick up on the overlays and all that, and this is a step further to that. Network analysis is basically a set of connected lines. These lines represent railways, streams, roads, water lines, pipelines, telecommunication lines, and so on and so forth that normally need to be analyzed as networks. It can be direct and indirect or planned and unplanned. Network analysis, the movement of people, connectivity or accessibility of railway, roads, pipelines, telecommunications, flow of matter, energy and movement of goods and services. So, any type of network is connected by vertices and edges, and this network is measured and compared by plotting of graph and linkages of objects or features. Networks depends on topological properties, that is connectivity, adjacency and incidence. So, that means what we have to remember? Network depends on topological properties, and that is connectivity, adjacency and incidence, CAI, and these are very important aspects which we need to remember. The different types of operations which are possible through networks: number 1, shortest path analysis, best routes if we want to find out, closest facility, allocation, location allocation, OD cost metrics, network partitioning and so on and so forth. Stream network and basin road connectivity in Delhi University North Campus is shown in the figure that's there in the text that's given with this lecture. So, let's now talk about what is network. GIS networks are algorithm of interconnected lines termed as edges and intersections termed as junctions. So, we have edges and junctions. It works as a path for movement of people, goods and services. The object navigating the network follows the edges, and junctions appear when at least two edges intersect. Junctions and edges can have certain attributes affixed to them that increases the cost of traveling in the network known as impedance. For example, a road network can have speed limit attached to the edge, and a junction can prevent left turns. Networks are either directed, only one direction of travel is allowed within the network, or undirected, in which any direction of travel is allowed. So, all those things you can add, and then the model can work. In addition, network can be a set of linear features through which resources flow. Nodes, the endpoints of lines, are used as origins and destinations, and links the lines traverse from one node to the other. Nodes can have properties, but in network analysis we are usually more concerned with the characteristics of the links, as also written in the Larooney and Thompson in 1992. And these include length, direction, connectivity. Lines, of course, we all know must connect at least 2 points, and the patterns. So all those links have to be tabulated. That means we need to know the lengths, directions, connectivity, the patterns and all that. Say for example, in case we are talking about the river flow. Of course, we know we got a river flow the direction of downhill. It is the best example of an oriented network. The road connectivity can be either oriented or unoriented. That is one way or two way, and usually roads contain loops. Trains usually travel in both direction and between stations. One track, the railway network with smaller lines representing an unoriented somewhere, etc. in the network lines designed for travelers in one direction only for the safety purpose. Then we also have two-track networks, and they are represented by a pair of oriented links in a network, can be either an unoriented or unoriented network. The direction of network or the link can have other properties that represent the cost of moving along with the link. For example, nodes can have properties that might encourage or discourage traveler in that direction. I hope you all will agree with it. What I have talked about is that, say the moment you think of the river, river won't flow up, river would flow always downstream. The moment you talk of the roads, roads can have one direction or the second direction and so on and so forth. So that means all these things have to be predetermined and predefined. Let us talk about now network model in GIS. Network model in GIS have the potential to simplify the development of spatial analytical network functions through various types of data model. Many types of data model are transportation network or road network, utility network and stream network and so forth. These network function helps in planning, development and accessibility. That means, in case if we are talking about the planning, we are talking about the development, we are talking about the accessibility, what we need to do network analysis. So now, let us spend time as an example of a transportation network or road network. Road network, it includes roads, railway line, flight paths. It is generally undirected network because the edge on a network may have a direction assigned to it. The transportation route, the direction, speed and destination of travelers can decide by the person. So all these becomes layers, right? For example, a person in a car traveling on a street, transportation or road network model play key role in transportation planning, an analysis of the retail market, measurement of accessibility and so on and so forth, allocation of service and more. The understanding of the road network pattern provides the idea about the human mobility behavior, and that is something which we all know it. Sometimes, say for example, in case if there are some cities where you're moving, you know that people will move buses in the bus lane, whereas in India in some lanes you may find that people may just not be following that. So we also come to know the human mobility behavior too. Another model that I want you all to understand and note is utility network modeling. What do we mean by utility network modeling? It includes water mains, sewage lines and electrical circuits, different circuits which we have, and these networks are generally directed. Its path is predetermined. It can be changed but not by agent. I hope you agree with it. Another example for this is a stream network. It includes flow of stream in catchment. It is directed network because of the natural flow. This type of modeling is performed for the analysis of drainage based on terrain or digital elevation. It shows the detailed information about the connectivity of landscape and land use and land cover pattern. It measures the various attributes related to the linear, aerial, relief features of stream. Stream network model analysis the geometry, shape, size, drainage, density, landform, etc. Also, it helps in understanding the dynamic behavior of river flow that reduces the impact of floods and helps in socio-economic conditions of human supply of hydroelectricity, etc., etc. That means this analysis is so useful, it's helpful to everybody, you and me, and sometimes you all may be using it also. So after understanding this, let's now talk about the data requirement for network GIS. Clausen has given the description about the application of network analysis for positioning and navigation. Requirements for analyzing road networks. The system that we need, our system requirements are: number one, real time it should be, as far as possible, compact it should be, then address conversion function should be there. Another system requirement is the output should be visually display or synthetic voice. Then after system requirement, after knowing all that, let's talk of the data requirements. Obviously, the first and foremost, data has to be accurate. It has to be up to date, that means current, topologically correct, required attributes. Say for example, there is some construction going on, or you find that this road is now directed from this to this, we need to correct it. Topologically corrected it should be up to date, required attributes should be there, and then the road conditions should be noticed. And in case if we talk about the road conditions, again further, if it's possible, classification should definitely be done. Speed restriction should be noticed, because we all know that somewhere you can drive at the speed of 70 km per hour and somewhere you can drive it for 50 km per hour. We should be knowing that also. Then one-way streets or two-way streets, then turning restrictions also. Some places you can make a U-turn, some places you cannot do that. All this knowledge should be there. Then the width and height restrictions, junctions, roundabouts and all that. So all this information should be predetermined and noted and entered. Okay. So once you know about all that, so that means what I am trying to tell you is that you need to visualize, you need to work out that what need to work out and then only go ahead and perform network analysis. So now let's talk about the operation of the shortest path. Nowadays you all are using your Google. The moment you leave your home, you just pick up your mobile and just open it and see where is the shortest path, which is the one which is not congested. Yes, all that what is done is being done by network analysis. It's a common type of network analysis. This operation is the shortest path. It helps in finding the shortest path between 2 points. In a network of streets, the shortest route is analyzed for different variables, that is distance, time and monetary cost in terms of purchasing travel tickets or transportation of goods and services. For example, an ambulance driver look for the shortest path to his destination for traveling the route assigned to him or her from point A to point B in the least amount of time. The fair price of purchasing the plane tickets, you use that. Then you are getting late for your office, you may use again this. We all do it. Another example is a traveling salesman. Sales always travel in order of the network of markets. It's most efficient way to reach the market and sales a product. And the network post of salesman depends on the quickest time in reaching the market product and demand of the market and connectedness of the market. For example, an Amazon agent have to deliver the products of any area. Like nowadays it is Diwali and the gifts have to be done. He'll follow the path of first route of demanding product and quicker time of network route, obviously. UPS uses a traveling salesman algorithm to professionally deliver as many packages as possible to their customers every day. See how useful network GIS is? Another thing that we talk about is network partition. Network partition refers for the subcategorization of network for particular purpose. The size of the network region depends on the proximity to specific point in a network. For example, coverage area of the first station are divided in the metropolitan region, and the network of Indian Railway network divided in many zones as per the regional proximity of the state. Next example, let's talk about the transportation model. Other basic functions like buffer, overlay, query, which you've already done in GIS operation, are useful in planning. Transportation, however, there is many model available for the detailed in-depth analysis of the network data is available for planning application, like network flow, equilibrium model, travel demand models, trip generation and distribution, as well as activity based models and transportation or land use interaction models. The usefulness of these models are dependent upon particular use as per demand of transportation, influence on land users. There are limited commercial software exists for perform such tasks. Nevertheless, skilled programmers should be able to design program to perform these tasks where software is inaccessible or non-existent. GIS is key for the analysis of these type of transportation models. Isn't it great that you're learning GIS? Let's now talk about another aspect, that is network analysis workflow. What are we going to talk about? We're going to talk about network analysis workflow. In order for you to perform a network analysis in a GIS program, there are basic steps you need to take. And this section walks through the general procedure to do before you solve your network analysis network problems. Number one, what you need to do? You need to organize the network analysis settings. You need to, what did I say? You need to organize the network analysis settings in any GIS system. So, for example, the ArcGIS, you need to enable the network analysis extension. You will also need to display the network analysis toolbar before you can perform any analysis. Adding a data set to your GIS program before you see able to perform a network analysis, you need to create a data set network in which you can perform an analysis. If there is not one available, the original reference source has been modified or has been changed, you will need to build a new one. Alright, so that's very important. Second step is you need to create the network analysis layer. So, what is the second step? You need to create the network analysis layer. Layers contain in-memory classes where inputs, properties and results can be stored. And in the case of performing network analysis, the layers has to be connected to a network data set, and this layer has to be created and added to the data set before the analysis can be performed. In ArcMap, a network data set must be added first, and so that when an analysis layer is created, network analysts can bind the analyst layer to the network data set. The 6 kinds of network analysis or layers in ArcGIS, in case if I go by that, are number 1, route analysis layer, closest facility analysis layer, service area analysis layer, OD cost metrics analysis layer, vehicle routing problem analysis layer, and the location allocation analysis layer, and then you overlay. So, that means all the layers, that is the first and foremost is to visualize what are the layers which are there in case they want to do the network analysis. Next, the third step is inputting network analysis features and records. This step has us add features or objects to our dataset input. Network analysis objects are features and records used as input and output during network analysis. And these objects can include, any guesses? Yes, the first and foremost barriers, then routes, then facilities, then man-made structures that will influence the analysis. And when you add this object setting, the properties for the network analysis layer will further define the function of the input. And ultimately then you come with the performing the analysis. After you have finished the other steps of the procedure and created your layer, it is time to perform a network analysis. This can be done by clicking the solve button on the network analysis toolbar you set up early in the process. Your result will then be displayed on the map, and double click the network analysis object in the network analysis. Right, this is clear? Yeah. So now we've understood how to go about it, we have understood how to do it, what are the steps need to be followed. What is network? Yes, it's not just one layer matter, you need to create layers, so that what are the things which would be there, yeah. So now let's just spend little time on the applications of network analysis. In GIS, network are used for more than just finding shortest route, of course. Resource allocations, isochrones, constructions and many other operations require network data. So first is the routing. Finding shortest route is probably the commonest routing problem to occupy GIS users. Find the shortest route from A to B through a node network is crucial for emergency service, business journey and so on and so forth, and that's something which falls into this. And so that means what is important to construct is an appropriate network. Details of connectivity, one-way streets, possible turns and so on is an example of how information can be stored for a simple road network, and even a figure shows that. Then there are few features that are commonly encountered on road network which may present problems also, right, and these problems also have to be captured, spatially captured. Say for example, different access permissions or turning restrictions, some of these can be modeled using the types of system described above. The network should also be capable of taking new information and recalculating the routes, right. So, new calculation also, integration should be possible. Once you have designed and popularized and populated your network model, then the algorithm can be used for calculating the shortest route. If street names or number is held as an attribute for each line, then these may be printed out to form a written set of direction. Then there are some problems for which no efficient algorithms are known and in which heuristic are all we have. The traveling salesman problem, TSP, is one of these. The traveling salesperson has to visit a number of customers, then return to the base. So, he or she need to have details of the shortest tour possible, so that to the sites. And this is obviously application for shortest tour routine. But there are many others also, for instance, giving direction to a doctor, visiting patient in the community. Then it is also possible for a traveling salesperson to traverse the same road twice. Now, the traveling salesperson problem has attracted the attention of operational researchers too. Using a simple method of calculating the shortest distance between stops, theoretical methods have then worked out all the combination in which these stops could be visited and find the shortest tour. This sounds simple, but for the computer it is a major task. Yes. If for example, there are 10 patients to visit on a doctor's round and there are 9 factorial combination in which they can be visited, what this means is that the total number of combinations is 362880. That doesn't sound too difficult for a computer, does it? But try this on your calculator. There should be X factorial button, and somewhere on most scientific calculators 9 factorial also, they receive so many and so many. But imagine a human being going through so many combinations, it is just not possible. So, but the network analysis helps you, it performs that action, and finally you can compare the total distances traveled to identify the optimum solution. And this complexity explains the interest shown in the TSP by mathematical friends, but we still do not have the efficient algorithm. So, how do shortest tour option work in GIS? Vincent and Delay, they offer 2 possible solutions. One is to use fractals. However, this is really at the research end of the GIS at present. For those who know something about the fractals, the method involved applying space fitting curves to find which nodes are the closest together. Second is a cheat. That is how most current solutions work. If you first order the slops based on their attributes, it is much quicker and less computer intensive in work out the shortest route. As Vincent and Delay note, however, that there is a problem with any of these methods. In the real world, the stops which appear closest on the GIS map layer may not be close. There may be a Grand Canyon to create between the 2 points. So, once again the answer you go from your network analysis operations are only as good as the representation of the network, and we all know it. Intriguingly, there is a very similar problem TSP for which algorithms do exist. This is known as the MST, minimum spanning tree problem. The only difference is that the route only needs to connect to all the points using the shortest path. It does not need to return to the chart. This has been implemented in GIS. Let us look at another application, say of the resource allocation. Another application of the network analysis is of course resource allocation, and the objective is to create service areas around service centers, and if implemented successfully, it will allow an organization to optimize the distribution of the resources based on the capacity of each facility. I hope you agree and understand this resource allocation. For example, I will elaborate. Centers may be schools with a maximum capacity for children, health centers with a capacity for patients, or warehouses with a capacity for goods. Allocation algorithms use these centers as destination, then model how people or goods will travel through the network to get there. The result is a map that shows the area served by each service facility. Example, say there is a school or a health center catchment area or the warehouse distribution area. Algorithms usually work by allocating links in the network to the nearest center, taking into account, of course, the attributes such as one-way streets, barriers to the movement, and so on. Applications of such resource allocation operations include citing new schools, revising catchment areas for hospitals, or modeling the effect of closure of service site. An interesting example of the use of the method in an archaeological application is given in the paper by Zuguru, and I want all of you to read it. Next application, we can call it an application, is related to isochrones. What are isochrones? Yes, you know isobars, you know isotherms, you don't know isochrones. Okay, isochrones are lines joining points of equal time. Applications of the operations areas for finding travel to work zones based on how long people will travel to a center, or for the establishment of cost service, or zones for transportation of goods and services. Okay, so that's isochrone. For example, there is a furniture retailer. He may define zones A, B, and C around the retail outlet. Okay, and if you live in zone A, you can have good delivered free of charge, and if you live in zone B, you will be charged a nominal fee, and if you live in zone C, you will be charged an exorbitant fees, because they don't want to have to send the delivery vans that are very far. Alternatively, isochrones could be used to predict the dispersal of pollutant through a river network from a point source. See, such a great application. GIS will produce a set of isochrones for a center based on the time it takes to travel along the links to the network. As with the previous operation we discussed, all the attributes, speed limits, capacity, and so on can be incorporated into the operation to obtain realistic result. This will result in the identification of points in the network links which represent the distance traveled in the time given. And interpolation techniques could be used to construct a surface from this side of points, and the surface is then reclassified to extract an area that could be reached in a specific time. An alternative approach would be to identify those points, perhaps representing bus stops, train stations that can be reached within a specific time, and then buffer them to show zones with the shortest walk. This approach was applied by the Pittsburgh Foundation as part of an access to work study based on PAD, and you all can also do it for your own study, obviously. Network analysis design issues, and many GIS will claim to contain network analysis operations. However, the majority at present only have capabilities for calculating shortest routes. Some may allow calculation of shortest route based on travel times, but most will stick to shortest distances. The more sophisticated network modes will allow the addition of attributes such as speed limits, turn restrictions, and demand to make the operations more realistic. The market for in-vehicle navigation is growing. It combines GPS and network analysis technologies to perform or to provide a user with a dedicated set of product and software. That's which is so important. So that means now, after completing this lesson, I think so you all are thinking of great ideas to use a network. And you are using it also. I know that your smartphones are forcing you to use and perform network analysis. So now let's summarize what we have learned today. One is we have understood the relevance of the word called network. And what is it? Network is a set of connected lines. Network can represent rivers, roads, water lines, and so on, telecommunication lines, and so on. Networks can be directed and undirected, planar and non-planar. In GIS, networks are widely used for two kinds of modeling: transportation network and utility network. And network analysis analyzes the way goods can be transported along these lines, right? And we've got a lot of examples. We also know now what is undirected roads. Network analysis can be done in raster and in vector. We can do different types of operations. Guess, name. shortest path analysis, best route, closest facility, allocation, location, allocation, OD cost metric, network that partitioning. That I really wish that you all use network analysis, and I know you will use it. Thank you very much. This is my favorite topic. Thank you.